Howdy, we're Team Gyneco, and today we'll be doing a teardown of the Clear Blue digital pregnancy test, which has a smart countdown for results and gives you a clear message on whether you're pregnant or not pregnant. This device is different from its predicate because it gives you results 5 days sooner than from your missed period, and it provides you 2 tests instead of 1. So taking one of the 2 tests out of the packaging, we see that there is a blue foil that covers the device. This is meant to protect against water damage and other environmental factors that would damage the device. So when opening the device, we see that the device is small and handheld. So besides the clear labeling, we see that there's a digital component and a cap that is meant to protect the absorbent strip. So looking at the materials of the device, we see that the 2 plastic coverings are made through injection molding. Looking at the tip, at the absorbent tip, we see that it's made out of cellulose filter paper. This allows urine to flow into the secondary component device through capillary action. There are 2 ways to get urine onto this device. One is through directly letting urine flow onto the device for 5 seconds. Another way is to get a cup of urine and to dip the device into the cup of urine for at least 20 seconds.
So now we're going to use a screwdriver to try and tear open the device. Ta-da! So upon breaking open the device, besides the 2 plastic pieces in the absorbent strip, we see an immunoassay testing strip, followed by a desiccator and a 3-volt lithium Panasonic battery. As we turn the device to its side, we see that there is the digital component, which is connected to the sampling area by a circuit board and a microprocessor on the inside.
As urine flows up the absorbent strip, it binds to antibodies on the immunoassay testing strip, and dependent on the HCG concentration in the urine, will cause a color change accordingly.
On the inner portion of the device, we can see 3 holes, and behind each hole there is an LED light powered by the battery, and those lights will shine onto the immunoassay testing strip. So the 3 LED lights are controlled by a microprocessor in order to carry out spectrophotometry. This is used to determine the concentration of HCG on the testing strip using the absorbance level of the light of the substrate on the testing strip. Each hole that has the LED corresponds to a different zone. One measures the absorbance in the testing zone, the second one measures absorbance in the control zone, and the third one measures absorbance in the reference zone in order to enter these values into the algorithm to compute the HCG concentration on the testing strip. So behind the 3 LEDs, there are 2 photodiodes. These photodiodes will create a current based on the intensity of the light absorbed after the LEDs shine through it. And this current will travel through a circuit board and will go to the digital readout, which will detect the current and have a result displayed, pregnant or non-pregnant, based on the intensity of this current.
To wrap up the teardown analysis, we can see a desiccator, which primary function is to absorb humidity in order for the device to function properly.
So we created a sample algorithm of what is used in the device. The device in the big picture uses HCG concentration as an input, but this algorithm is after the LED lights shine and measure the absorbance through spectrophotometry. So the inputs are going to be the amount of light absorbed in each section that we talked about earlier. Testing section is used to measure the amount of light absorbed due to the concentration of HCG that binds to the analyte on the testing strip. The second section, the reference section, is used to control for the light absorbed due to urine color, possibly. The control LED it calculates the amount of light absorbed by the paper so that we can adjust for that in the algorithm. After we get all these absorbances, we'll take the top one minus the bottom two, and we'll take that number and divide it by a constant, and that, through a Boolean, will yield the result right here. Each LED will light up temporally in order to give a signal based on a time basis. And then after each LED lights up, it opens up into a while loop in which the absorbance at each location is put into an equation which will calculate the result. So although these inputs would not in reality be user-defined, right now we're going to control them as user-defined in order to get a specific output. And whenever you start the algorithm, it lights those all up and it will give you a final result.